All right, welcome back, scholars, to our back end of our exploration on probabilities. We are learning to interpret in written language two-way tables to estimate probabilities, including conditional probability, so I can use probabilities, including conditional probability, to justify that events are independent and dependent. Wow, that's a mouthful. I'll know I've got it when I can use probabilities and conditional probabilities to decide if events are independent. All right, so to begin, we're going to be evaluating some mathematical expressions mentally. I tried to manipulate these and determine what your final output is in fraction form. Yes, I know that we could use calculators here. However, with probabilities typically being expressed in ratio format, it is important that we have the ability to manipulate fractions at will. So a pharmaceutical company is testing a new medicine for a disease using 115 test subjects. Some of the test subjects are given the new medicine and others are given a placebo. The results of their tests are summarized in the table. If you're wondering what a placebo is, okay, it's basically a sugar pill where you obviously get none of the medicine, but then we just kind of, what kind of symptoms are you feeling, and people are like thinking. Um, so First things first, if one of the test subjects is selected at random, find each probability, right? So the probability that the symptoms were persisting, there were 68 total people out of 115, and then determine what's the probability of selecting somebody that's been given the medicine and their symptoms persist, that's been given the placebo and their symptoms persist. Divide the corresponding value in each cell by the total number of test subjects to find each probability to two decimal places. Some of the values have been completed for you. Right, so in the event of something like 26 divided by 115, get 0.226, so it can say 0.22. Right, so complete this table as you need to. And sorry, in this slide, all right, we have a few more probabilities, but we're getting back into our idea of conditional probabilities, right? The probability someone being selected where their symptoms persisted, given that they've been given the medicine, and vice versa. After these, please, from the original table, divide each cell by the total for the row, right? So the rows are horizontal. To find the probabilities with row conditions, some of the values have been completed for you. Okay, this is why we've deleted the total section. No need to, or the third row, right? So what are the probabilities based on given medicine, based on given placebo? We would do, or Jada decided to do an alternative strategy because she didn't read the instructions for the previous problem well, and use the table she created on the first problem to divide each cell by the probability total for each row. For example, in the top left cell, she calculated 0.27 divided by 0.5. Complete the table using Jada's method. What do you notice about her table in particular? At this point in time, right, determine the probabilities with respect to the column conditions and calculate those probabilities, and then decide if the events symptoms persisting and given medicine are independent events. Does being given this medicine have an impact on whether symptoms persist or not? Explain or show your reasoning. To wrap up our activity, we'll be looking at a blood bank. Blood types are grouped into type O, A, B, and AB. Each blood type either has the Rh factor or not. If a person is randomly selected from the community, the probability of their having each blood type and Rh factor combination is shown in the table. What does the 0.085 in the table represent? And calculate the following probabilities based on the data that we have in the table. So we don't really need to be doing much in terms of mathematical calculations since we've already been provided with the probabilities. So it's a mere identification of where in the table we are looking. And as I've told you before, it's critical that as you transition from young men and women to more seasoned adults, that you're able to interpret and formulate your own opinions based on data. Lesson 9 summary. And that's where we'll pause for this activity.